Years of IT experience with technical expertise in data science, computer vision, business intelligence, artificial intelligence, and machine learning, deep learning using Python, embedded systems, video processing, signal processing, medical imaging, image processing. He has an experience of 3 years in teaching with excellent technical, analytical, communication, and problem solving skills. He also has hands on experience leveraging generative AI, large language models, natural language processing, deep learning algorithms, computer vision, and machine learning algorithms to solve challenging business problems. His exposure to project management activities are requirement gathering, activities planning, implementation of activities. He is highly inclined towards research activities with 16 publications in international journals and conferences of repute.
Thank you, madam. Now I request Dr. Zahir Ahmed to take over the session.
Thank you, sir. Thank you, Manasa, for a wonderful introduction. Thank you, madam. So I hope I am audible. And
yes, sir.
Yeah, thank you, sir. So let me share my screen. So as introduced, I am Dr. Zahir Ahmed Mullah. So I'm presently working as a technology lead in Samsung. So today I'm going to give a brief overview of natural language processing, NLP, which is one of the emerging technologies as a part of generative AI and deep learning domains. So I'm expecting that people have a basic understanding of NLP, and most of my session, because I'm into I see that more people are from faculty background, so teaching background. So I will try to keep this session as precise as possible, and I'll not go into technical details, into the much technical details, but I'll be more focusing on the hands-on expertise and hands-on things which you could carry out after you complete this session. So I'm hoping that I'll just give a brief intro to this particular topic, that you could take it forward after you complete this FTP. Okay, so that will be my primary objective, keeping the time in mind. So let me start the session. So I'll share my screen. So I hope my screen is visible. Can somebody confirm?
Yeah, now it is visible. Yes, sir.
Yeah, okay. Okay, thank you, sir. Thank you for that. Okay, let me start. So yeah, basically the topic that I have taken up is natural language processing using NLTK. NLTK is actually a library, natural language toolkit. Okay, that is a library that is useful for implementing something that we learn on NLP. Okay, there are many other tools as well, but this is the most widely used. So first, I have two parts of my session. The first part, I will be covering the basics of NLP. So what all is natural language processing? What are its application areas? Right? What are the steps that are required to build an NLP pipeline? Okay, and what are the research that is going on in this domain? So that will be theoretical. Then following it up, I will be in the part 2 of my lecture. I will be covering how to implement the basic concepts of NLP using a library called as NLTK. Okay, so it is a very simple library. It will not be much coding. Don't worry, there will not be much coding to work on. Simple statements, Python statements. We can do it all the tasks that are present in the NLP. Okay, so yeah, this is what my lecture will be organized. So let me go ahead. So I think most of you might be knowing about NLP. So I'm assuming that we are all aware of this word called natural language processing, right? Nowadays, right, it is a very vital part of computer science and artificial intelligence domain. Okay, so we have a lot of right applications that are present in this thing. Okay, so firstly, as a brief, so here we are calling it as natural language processing. That means, right, how is it different from the earlier domain? So in the earlier domain, before to NLP, right, or why is this specifically called as natural language processing? Because earlier we used to process information, or we used to process data, okay, that we have, but this information or data will be in a coded form. Okay, it is right, you can take any language, any high level language or machine level language or assembly level language. Okay, there are a certain set of rules which we call it as the syntax and the semantics. Okay, and we are processing the information, or we are processing all the information data in the form of right codes. Okay, so for example, if I take a C program, right, whatever I want to do, I have to write a code for it. Okay, I have to use some programming, I have to have a particular syntax, right? So whereas this is what exactly is to happen in the right earlier days. Okay, where the information or where the data that is passed to a computer will be or should be in the form of a code, in the form of a coded information. So now what we have is NLP is a domain wherein, right, NLP is a domain wherein we are going to, or we can process the natural language. That means whatever the language a human being speak. Okay, it can be English, it can be Telugu, it can be any other language, right? So your information flow, that means your command to the computer will be in the form of a simple English. Now you don't need to write, or you don't need to pass the commands in the form of, okay, a specific coded format. Okay, so that is a prime difference, or that is the area which got which we are calling it as NLP. That means you are going to do processing. Okay, that means you are going to perform some operations, but here the commands will be present in the natural language of the human being. Okay, for example, if you take a chat GPT, right, a chat GPT that we might be using, so we are giving the command, or we are giving the query in the form of a simple English text, right? It is able to understand the text, and it is able to generate the text and give it back, isn't it? So all this is what we call it as natural language processing. Okay, so in simple, right, we are making the computer to understand our language. Okay, the language that we speak, right? So that means we are making it to understand the the syntax and the semantics of whatever the human language is, instead of like earlier we have to study about the, like if I want to do some programming in C, I have to learn the syntax of the C, and I have to follow the semantic structure of the C, and then I need to write the program accordingly. Whereas in natural language programming or natural language processing, computer is made to understand our language. Instead of we learning its language, it will learn our language. Okay, we have certain libraries and certain tools which can make the computer to learn about the human language. Okay, so that is basically NLP is all about, right? So by which as I said, okay, in simple you can take this as this definition, right? It is a technology by which machines can understand, analyze, manipulate, and interpret human languages. Okay, so there is a lot of research going on, right? So we might have been using all of these tools, like in our homes we might be using Alexa, Siri, right? Okay, so many applications. Okay, Google text to speech converter, right? There is a Google translator. I will give you the list of applications in my further slides, but all of us might be using all these. These are all examples of NLP, right? These are all examples of natural language processing. Okay, so right, we will be going in deep to see what exactly happens, or how is the computer able to understand this text, what exactly are the steps that are involved in NLP. Okay, let us study one by one. Okay, yeah. So now the next thing is, so what are the main components of NLP, right? So there are two main components. Okay, the first component is NLU, second component is called NLG. Okay, first component is called as NLU, second component is called as NLG. These are the two components that we have in NLP. Okay, so it's you can imagine simple, right? For example, when I want to learn a new language, okay, as a human being, if I want to, let's say, understand Marathi, okay, or speak in Marathi, so what I need to do first, I need to have one skill called as understanding. That means right, there are people who can understand Marathi but cannot speak. Okay, similarly there are people who can understand Telugu. That means they will be able to analyze the right words and pick the meaning. Okay, so that's called as understanding. In the same way, right, when you want to add this capacity, that is natural language processing, to a machine, you need to have two stages. The first stage is NLU. NLU means in this stage the machine will try to understand the language. Okay, it will understand what is the structure of a sentence, what are the meanings of the words that we have. Okay, so that's called as NLU, right, natural language understanding. So here machine will be able to understand what the human is trying to speak, or what the human is trying to write. Okay, so right here you will be, okay, extracting a few information like entities, keywords, emotion of the text, okay, relations inside the text, semantic rules. Okay, that means which will come, noun comes where, verb comes where, etc., etc., all these all right, things. So these are all okay, what we call it as natural language understanding. That means interpreting the text. Okay, interpreting the text and getting the meaningful information from the text is what we call it as NLU, natural language understanding. Okay, that is a first component, right? The second component that we have in the NLP is natural language generation. Okay, that means it is like speaking the language. Okay, once you learned the language, you have learned the words, you have understood, okay, the meanings, etc., etc., then you can start speaking in the language, right? So that is called natural language generation, right? Natural language generation means the ability of a machine to generate the new text or new voice or new audio, new image, right? So generation means generating new data. Okay, so these are the two stages or two main components that are present in NLP. Okay, natural language understanding, natural language generation, right? In natural language understanding, our task is to interpret the text. Machine will try to understand what is there present in the inside the text. Okay, it will identify the entities. Entities means who is the speaker here. Okay, is there any organization, is there any place? Okay, so is a person mentioned? So all these, getting all these information is what we call it as entities. Then we'll understand the relationships between them, what is happening to this person, okay, or where is the person going, etc., etc., right? So with tools or with models we can perform all these things. Okay, so once you have the model, the capacity to understand the text, the next step will be to generate the new text. Okay, that's what ChatGPT is doing, right? You are giving a query, right? You're giving a query. So first what it will do, it will try to understand the query, right? It will, there are no don't get confused that there are, right, there are any like assemblers or machine level coders which will convert our query into machine level language or any other language. No, nothing, right? So in ChatGPT there is nothing like that. Okay, or for that matter any transformer model or LLM, large language models which we call them. So there is no kind of translation happening. It's only it's straight away, okay, the model is trying to understand what is being said in that prompt or query. Okay, whatever you give to the ChatGPT is called as prompt. Okay, in technical terms it's called prompt. In general language you can call it as a question or query. So whatever is present inside that query or question, first the model will try to analyze it. Okay, see what is present in it. Then it will, then what it does, it will take, okay, based on the query, it will do some processing. That is, it will go to its database, check for the similarity. Means for a given query, where is it, it is finding the exact result. Okay, in a database it will search based on the data that is given to it. Okay, for the training, it will search for those exact keywords and get back the data. Okay, and again it won't return the data in the same manner. Okay, whatever it is returning, it will not be same, right? That's why they say whenever you get something from ChatGPT, it is unplagiarized. There is no plagiarism. Why? Because it will not return the data as it is. It will instead generates new text from whatever it has retrieved. Okay, it has retrieved some information. So based on this, which is what we call it as context. Okay, so I'm giving you some technical terms. Don't get bothered. These are all small things that we need to have. Okay, so right, prompt is a question that we are going to give. So to your LLM, this is your large language model. Okay, which in this case is your GPT 3.5 or GPT 4 model. Okay, so you give the prompt. The prompt will be analyzed by the GPT model. Okay, then it will try to understand or figure out what are the keywords that are present, and based on these keywords, it will go to your its database. Okay, training data, right? And it will retrieve the most relevant context, means whatever for your given query, whatever is closest to it, okay, will be retrieved. Based on this, okay, LLM again generates the response and it will give you the response. Okay, so right, it is not returning as it is. Remember, it is not returning as it is. It is right generating the text and passing it to the user. So that's why every time you click so you will get maybe the dates or some places, they might not change, but if you ask it to explain about something or analyze about something, then what it does is every time you click, it might generate new text. Okay, it will not generate the same text again, exact same text again. So most of the part will be different, right? That's what is happening. Okay, this is the second step, which is called as natural language generation. Okay, so in simple, right, we have two important components in NLP. If I want to do any NLP task, I need to do these two things. Okay, so if I want to implement any NLP pipeline, okay, I have to perform these two tasks, NLU, NLG. Okay, so I should be able to understand the text, okay, with the help of this NLU models, and then I must be able to generate the text with the help of, okay, this right, okay, LLM models. Okay, so these two generally both are performed by a single model, okay, which we call as LLM, large language model. Okay, so it's a language model, means it is specifically trained to understand the language. Okay, understand the human language. Okay, so right, it will understand the syntax, it will understand the grammatical things, all these things will be okay, will be understood and will be analyzed by this particular model. Okay, so right, an LLM can perform both the things, right? So that's what basically the NLP domain is all about. So you need to cover these two concepts. Okay, yeah. So I hope this basic introduction to NLP, NLU, and NLG are understood. If you have any query, please let me know. Any query at this point of time? I'm not able to access the chat because I'm in the PPT mode. If there are any queries in the chat, please let me know as well. Anything? Shall I go ahead?
Yes, sir.
Hello.
Yes, sir. It is clear. You can proceed, sir.
Okay, sir. Thank you, sir. Okay. Next, applications of NLP, right? So these, where do we right, before we learn any technology, it is very much required to know where it is used, right? So as I said, okay, there are so many applications of NLP which we are using in the day-to-day and day-to-day life. So many things. Okay. First, you might have seen about this question and answering systems. Okay, so automatically ask the questions that are answer the questions that are asked by humans in a natural language. Like we have Alexa, Siri, right? All these systems are basically this. Okay, question and answering systems. This is one application. Okay, so we might have seen all this too often. Then spam detection. So spam detection is also a very old application of NLP. This has been there, from ages. Okay, so you might see in a Gmail or any mail, right? You have a category called as spam. Okay, so if how is it done? So you check for the subject of the mail, you check the body of the mail. There is a text that is present. So this text will be taken, all right, and based on the content present in the text, you classify whether it is spam or not. Even not only that, even now in Gmail we see that there are categories like primary, social, and promotions, right? So this categorization is also based on NLP. Okay, this is one of the applications, right, where we process the text that is present in the email, and based on that we do the classification. Okay, so spam detection is another example. Then sentiment analysis, right? This we might think this is silly, but believe me, this is one of the most happening applications in the industry, right? There are so many companies that are investing so much of effort and money into sentiment analysis in order to make the customer, in order to understand the customer, in order to understand the market structure for various kinds of products. Sentiment analysis or opinion mining is one of the key things that is happening. Okay, so we use LLMs and NLP to perform sentiment analysis from the Twitters, okay, Facebook accounts, product reviews from Flipkart, Amazon, okay, movie recommendations in Netflix, Amazon Prime Video, Disney Hotstar, all these things, right? All these comes under sentiment analysis, right? So this is one of the happening trends even now in case of NLP domain. Okay, this is one. Then machine translation, as I already told you. Okay, so we have Google Translator, but not only Google Translator, there are so many other translators as well in the market which can translate from one natural language to other language, right? So earlier, when we go to a new place, it used to be a big problem. Nowadays, it's not, right? Whenever you want to understand something, just take a photograph of it. Google Lens is there. Just take a picture of it, give it to Google Translator. It will tell you what exactly is the meaning of it in a particular language, right? So machine translation is also based on NLP. Okay, yeah. Then spelling correction. So whenever we have Microsoft Word or even the emails, everywhere we are seeing that there is spellings are getting automatically corrected. That is also based on NLP. Okay, so we perform all these tasks using natural language processing. Then speech recognition. Okay, so speech recognition, like in the Google voice assistant, okay, or the voice devices that we have, all those are examples. Okay, even in YouTube or Microsoft Word, we have voice searches. Okay, based on voice we can give the search. That is also example for speech recognition, right? So these are all examples of it, right? Chatbots, of course, again, as I said, one more after sentiment analysis. Now every company or every major organization is coming up with their own chatbots to make the user experience friendly, right? All the banking applications have their digital assistants, okay, in their websites, to make sure that the user experience is smooth. Okay, so chatbots are again one of the major applications where we are using NLP, right? Completely it is based on natural language processing. Yeah, so these are the few applications. Not only this, there are so many other applications as well, right, that are available, that are where we are using natural language processing. Okay, now, so we understood two things as of now. So we understood what is natural language processing, right? What are the components that are present? So we have NLU, we have NLG, natural language understanding, natural language generation. One is used to understand or analyze the text that is present. Other is used to generate the new text. Okay, both activities are performed by something called as LLM. What is LLM? Large language model. Okay, right. Then we have seen various applications of NLP. Okay, so the next topic and the most important topic of this lecture is how to build a NLP pipeline. That means what are the components or things that are present, steps that are present, right, when I want to do natural language processing. Okay, right. So let us go one by one. So first we will cover the first part, that is NLU. Means I want to understand what exactly is present in a particular sentence. Okay, I want to analyze that sentence. Okay, I in the sense machine, you are passing a text to machine. Okay, in that case, how does the machine understand, right, what is present inside the text? Okay, and how does it use to perform all the other applications? Okay, so that's what exactly we are going to cover first. Then we will be covering how to generate text. Okay, text generation is pretty easy. Okay, it requires transformers. Okay, transformer architecture and transformer models. So we will see if we can cover that. Okay, if there is time we'll cover it, but we will see the first part, okay, in detail, right? So first step, okay, the first step in building the NLP pipeline is the sentence segmentation. As I said, the basic input to this will be a sentence. Okay, the basic input will be, you have a paragraph. Okay, you have a text, right? We are giving a text to machine. Okay, now what is happening inside, or how is the machine able to understand the text that is given to it? Okay, so the first step in that is the segmentation of sentences. Okay, sentence segmentation means, okay, in the given text, right, there will be paragraphs, there will be right, many pages, and all the page there will be paragraphs, right? Paragraph is the basic entity of, let's say, English language. Okay, now the first step will be is to divide this paragraph. Okay, you have a paragraph, this paragraph will be divided into sentences. Okay, that's called as sentence segmentation. Okay, so the first task will be to segment the given sentence, given paragraph into various segments or sentences. Okay, so we will be processing every sentence as a particular, okay, document. So here I have two important definitions. Okay, so first definition is called as corpus. Okay, yeah, sorry for that, where is it? So I have two important definitions, okay, which are quite often we encounter in NLP. One is called as corpus and other is called as document. Okay, so what is corpus means? Corpus is the entire text that you have. Okay, in a given document, sorry, in our file, you can, let us assume this is a file. Okay, so in a given file, whatever the text that is present, that is what we call it as corpus. Okay, that is what we call it as corpus. Okay, so right, this is what we call it as corpus in NLP, right? The entire text that is present is called as corpus. Each sentence that is present in the corpus is what we call it as document. Okay, so in NLP, right, I call document as a sentence, right? Every sentence will be taken as one document. Why is this important? These are very important where when we do the further processing, we'll understand that when we go ahead. Okay, so these two definitions, please do remember, corpus and document. Corpus means the entire text that I have. Okay, the entire text that I have is called as corpus, and each sentence in the entire text will be called as a sentence. Okay, right? So you could see an example. So this is how sentence segmentation happens. So I have, okay, right, this paragraph, Independence Day is one of the important festivals, something, right? So this will be now converted into, okay, sentences like this. This is the first step that happens whenever we are performing, okay, NLU. Okay, so whenever I want to do the analysis, the first step for me will be to divide the paragraph or divide the entire text, okay, into sentences. Now we see the data in terms of sentences itself. Okay, that is the first step, right? Second step is, now the second step will be, okay, we take each document. Okay, the second step will be, the input to this second step will be a document. Okay, so that means a sentence. Now again, this sentence, every sentence will be converted into words. Okay, individual words. Okay, so it can be, all right, one word. Okay, it can be one word or two words and so on, or n words. We can have n words as one token. Okay, so if I take one word as a token, it is called as unigram model. It's called as unigram model. If I take two words as a token, it is called as bigram model, right? So, right, okay, and if I take n words as a this one, right, n words as a token, it's called as, right, a n-gram model. N-gram model. Okay, so if you take chat gpt is a unigram model, right? That means even if you give a single sentence, okay, single word, still, right, let's say if I just type politics, okay, or cricket, it will give you a text. Okay, so, right, it is a unigram model. That means every word will be taken as one token. Okay, every word will be taken as one token. For example, right, there are like if you take the Mistral from Meta, that is Facebook. Okay, so if you take Mistral LLM, Mistral is a bigram model, so you need at least, okay, two tokens to generate any response using Mistral. Okay, everything has advantages and disadvantages, right? Unigram model and bigram model has, right, advantages and disadvantages. Okay, but the difference is, if you give a single word to your Mistral model, Mistral LLM, it will not generate response. Okay, it takes two words as a minimum, so two words as a token. Okay, it's a bigram model, right? In that way, we have like various, for example, if you take this T5 FLAN, okay, T5 FLAN, which is a text processing model, T5 FLAN model. So T5 FLAN uses trigram strategy. That means it takes three words as one token. Okay, as you increase the number of words in token, what happens is the word similarity increases. Okay, you will get more precise answers, but sometimes it is also possible that you will get irrelevant answers as well. Okay, so as I said, both have advantages and disadvantages, right? So this is what the next step happens. So first, you divide your text into documents, that is sentences. Again, each sentence will be divided into tokens, which is called as tokenization. Okay, this process is called as tokenization. So that is, right, you will divide the entire sentence into tokens, separate words or tokens. So you can take one word as a token, you can take two words as token, you can take three words as token. It's your wish. Okay, so based on your requirement, you can take, okay, whatever the model you are using, right? So that's the second step. Okay, first step, we divide our text into sentences. Second, we divide every sentence again into words. Okay, right. Next step is stemming. Okay, so what is meant by stemming? Stemming is basically, right, you have the definition here, but I'll tell it in a simple way. Okay, so what does stemming means? Stemming is like, for example, like I am playing, okay, cricket, okay, every day, something like this. Okay, I have like this. Okay, I am playing cricket every day. Okay, okay, I play on the evenings. Okay, so let's say we have a sentence like this. Okay, now what happens is, if you take this word, right, playing. Okay, so generally whenever I go to back, okay, in the further steps we'll come to know, okay, more precisely why stemming is required, but I'll explain you what stemming is. Okay, I have two, right, words here, playing and play. Okay, so, right, the process of stemming is a process in which, right, you have words like playing, plays, okay, played, right, all these are called as derived words. All these are derived words from the root word called play. Okay, so stemming is a process basically in which you convert the derived words into their root form, okay, or base form, right? So like we have the words like coming, okay, came, okay, all these are will be mapped to come or go, like that. Okay, going, gone, went, all these will be mapped to a word called as go, right? So stemming is a process in which you are removing the, right, removing the additional part, or just like you're converting the derived words into, right, base words or root words. Okay, that's called as stemming, right? How do you do that? Right, how do you do that? Simple. What we do is, in stemming, okay, we will either remove the prefix or suffix of the word. Okay, we imagine that the main word is the center one. Okay, so whatever, right, the main root word will be present in the, okay, in the center. Then we can either remove the prefix or we can also remove the suffix. Okay, so we have both the techniques. We can remove the prefix, we can remove the suffix, right? So this process of removing this additional part to get it into the base form is what we call it as stemming. Okay, stemming means cutting down. In simple words, you can say it as cutting down. So we are trying to cut down the prefix or suffix, okay, based on our wish. So this process obviously can lead to errors, right? Sometimes, okay, you already, the word might be already present in the root form. Okay, again, when you remove the prefix or suffix, then there is a problem to get, right? So generally, we have certain prefixes and suffixes like ly, okay, ed, right? These are all suffixes that we consider. Okay, so removing them will convert them into base form. Okay, why is it required? I will tell you later. Okay, why is the stemming required? Why can't we process all the words separately? That I will explain you in the next step. Okay, but understand that stemming means I am going to remove either the prefix or suffix of a given word. Okay, so that's basically stemming is all about, right? So I hope you have understood. Let's go ahead to the next step. Next step is lemmatization. Okay, so, right, next step is lemmatization. So lemmatization is almost similar to stemming. In fact, both of them work or do the same thing. Okay, so, right, you could see here. Okay, so again the same thing. You have a word. This word will now be converted into its root form, okay, or its base form. Okay, same as that of stemming, but what is the difference here is the process. Okay, in stemming, what we have done, we take a derived word, okay, or we take any word, right? Now what we will do, right, we will remove the prefix or suffix of the word to get the root word. Okay, this is what is happening in stemming. But in lemmatization, I don't do that. In lemmatization, right, okay, there is a dictionary. Okay, I will keep a dictionary wherein I have, okay, two things. I have the root word or the base word, and I have the all the derived forms of this root word. Okay, so let's say if I have a word called play, So I will have all the derived forms like place, playing, played, etc., etc. in the derived form. So I will keep a dictionary. Okay, I will keep a dictionary, right? So what I do is I will pick up every word, every token, right? Pass this to the dictionary, right? And see what is the right is if it is present. Okay, it will be present in one of the derived words. So whenever it is found matching, you will pick up the root word or base word from that, and you replace this derived word with the root word. That's it. Okay, you understood, right? So we will take every word. Okay, we will take every word, we will do the comparison in the dictionary, we'll see where it is matching, and whenever the match is found, okay, we'll replace the derived word with the root word from the opposite column. Okay, like this. This process is called as lemmatization. Okay, this process is called as lemmatization, right? Okay, so for this lemmatization, right, we require a dictionary. Okay, we require a dictionary of words where you have all the words and in the root form and in their derived forms. Okay, and here whatever the root word that we get, that is called as lemma. Okay, that is called as lemma. So this is right, the word lemma is called as the root word, or right, the word in the base form. Understood? So this is basically the difference between stemming and lemmatization. Okay, so in stemming you do the same thing. In stemming, what we do, we will cut down the word either in the prefix or in the suffix to make it into its base form. Whereas in lemmatization, what we'll do, we will not remove anything, rather we use a lookup table or a dictionary, and we'll compare every word in its derived form with the root word or base word. Okay, that's the thing. Huh. So yeah, we have completed like effectively 3 steps. Okay, first step, step 1, we have the entire text. This entire text will be broken down into sentences. That is the first step. Okay, so every sentence is called as a document, right? Next, second step is you take every document or sentence, divide this entire document or sentence into smaller pieces, which we call it as tokens. Okay, a token can be a one word or it can be multiple words as well. Okay, so based on our requirement we can decide. Okay, next, once the tokens are generated, the next step is to convert these tokens into their base form. Okay, so why is it required? There is a we will save a lot of memory, and processing complexity can be reduced. Okay, that I'll explain in the coming slides. So we will convert our base derived words into root form with the help of either stemming or lemmatization. Sometimes we can use both as well. Okay, so that's all about the first 3 steps. Okay, so I will stop it here. Any queries in the first 3 steps? Are we good to go? Of course, I understand this is all theory, and you might be having this session after the lunch. So the things, but these are all the basics of NLP. Okay, if you learn these things, then we can implement right anything on NLP, and we can do a lot of projects, research on NLP as well. Okay, so these are all basic fundamentals of NLP, right? So any
Sir, I
queries?
have a query.
Yeah, please go ahead.
Sir, in first step, that is tokenization, in your sentence, comma is also there. You take full stop as token, but is a comma is also a token?
Where is it? Here.
Yeah, tokenization. In tokenization, sir. Step
Okay.
second. Yeah,
Uh-huh.
here. Java Point offers corporate training, comma. So
Huh.
is comma is also a token?
Yes, comma is also a token. It is also a token. We can take it as a token. Full stop is also a token. You could see I've taken a full stop
Yes.
also as a token. Yeah.
Yes. Okay. Thank you.
Okay. Thank you. Uh, any other query in that? Anybody else? Okay, so I hope I'm able to convey you the things as a part of NLP until this point. So I hope everything is clear. Let us go ahead with the next steps. Okay, so once I got my sentence. Okay, I have divided that into tokens. Okay, next I've converted them into root words. Okay, the next step is to remove the stop words. Okay, so what are stop words here, right? So the step 5 will be identifying the stop words. So what are stop words? Means in English, there are words which are actually added only for grammatical purpose. Okay, so they don't convey any meaning or context. Okay, words which do not convey any meaning, okay, do not convey any meaning, or called as stop words. Simple. Okay, so they don't add any uh, add any value to the context or any value to the meaning. They are just present because of grammatical purpose. Okay, so for grammatical purpose I have added them, right? So these kind of words are called as stop words. Okay, so if we remove stop words, what will happen? Our the size of the vector, and ultimately, okay, we have to convert our text into a vector form. Okay, ones and zeros or some vector numerical form, right? So that is our end goal, ultimate goal. Okay, so when I want to do that, what I need to do is, so I need to have the vector size as minimum as possible, isn't it? So if you look, if you take GPT model, a chat GPT, right, we are all using the free version. Okay, but in real time, or whenever I want to do a research project, right, I cannot be I'll not be using the chat GPT application, but I have to use the GPT model. Okay, GPT 3.5 or GPT 4 model. So when I want to use that model, right, I need to purchase the tokens. I think have you used the GPT model? Anybody? There is something called as OpenAI Playground. Are we aware of that thing? So please have a go through of it. Okay, there is something called as OpenAI Playground, where we will have our model, right? We are using the application. ChatGPT is application built over GPT 3.5 or GPT 4, or now recently we have GPT 4o. Okay, 4o is the latest model, right? So okay, so these are all models. So if I want to use that model in my project or in my application, right, I have to get a subscription, right, and I have to pay some amount. And how do we pay? Right, it is not based on monthly, or it is not based on daily. It is based on number of tokens, means number of words that I'm going to process. Okay, I'm hitting. Okay, so right, in my application, the number of words matter a lot. Okay, currently if you take the 4o model, right, for every word you want to process, it will I will be charged about 15 paisa to 20 paisa based on the model, 32k model or 16k model. Okay, so right, so for every word I have to pay 20 paisa. So okay, so if there are a lot of words like commas, full stops, question marks, is, and, was, like this, then I'll be paying a lot of money, right? So what I need to do, I need to remove all of them. Okay, so that's what we do in the next step. Okay, so identifying the stop words and removing the stop words. Okay, so how do you identify the stop words? Okay, so for this, right, there are multiple approaches. Okay, we can generally, whenever we are building our own application, okay, so like in real time I am building my own model, my own application. Then what I do is I create a library myself. Okay, so I will create a dictionary, okay, or a library, and I'll put all my words, whatever the words that are right, that I might see. Okay, so I'm building an application. So I can see that there will be coming, these words might be coming, which are not at all important. So I can create my own right corpus, or my own set of library of stop words. Okay, this is the ideal case, right? If not also, then in inbuilt, okay, if you take any tool, for implementing NLP. So for example, I have NLTK, okay, or Spacey. These are the two popular models, okay. So NLTK or Spacey, there is a default library of stop words. We can also use that library as well, right? So okay, one is we can define our own custom set of stop words. This is also fine. Or otherwise, what we can also do is we can use the inbuilt library of stop words, which will consider standard stop words. Okay, so there is a standard set of stop words like all the punctuation marks, okay, punctuation marks, question marks, like prepositions, there are few like conjunctions, prepositions, all these things are considered stop words in this library. Okay, so we identify, we import that library from the NLTK or Spacey, and then we pass every word to the to that uh, you know stop word remover function, okay, or model, and it will check first whether it is a stop word or not. If it is a stop word, it will automatically remove that word. If not, it will be returned back to the sentence. Okay, so in this manner, every word, every token in your sentence will be passed to the parser, that is to checker. Okay, so it will check whether it is a stop word or not. If it is a stop word, it will be removed. If not, it will be retained back in the particular sentence. Okay, so this is the next step that will happen. Okay, identifying the stop words. As I said, the main purpose of this is to reduce the complexity, reduce the vector size, and also reduce when we reduce the vector size and all these things, so cost will decrease, complexity will also decrease. Okay, so there is a lot of research, open and research that is going on the stop word removal as well. So this is also a very important research topic which can be taken up to improve the token usage. GPT token usage is a very huge scope for research, right? So there is a lot of research going on stop word removal and stop word filtering. Okay, yeah, so that is the fifth step that we have. Okay, uh, next step that we have is the dependency parsing. Dependency parsing is basically used to find how all the words used in the sentence are related to each other. Okay, so this is also called as similarity analysis. Okay, similarity analysis. Okay, so similarity analysis. Okay, and this is right in the most popular thing. It is also called as self attention. Okay, so attention, right? You might have heard about attention layer in the transformer architecture, right? So okay, attention mechanism, or dependency parsing or similarity analysis, all of them are seen. So what it does is it will try to understand, okay, the similarity or the dependency, okay, basically dependency of every word, okay, on the other words, in the token or in a sentence. Okay, you have a sentence, let's say there are 5 words in the sentence. Okay, so what we do is for every word, okay, I will check the self attention of this word with the other 4 words that are present. Okay, so that's called as dependency parsing or self attention mechanism. This is very, very important process that happens, based on which we are able to understand text and understand the generate the text. Okay, so all right, as of now in the LLM models, it is added as a layer in the network. Okay, in the network it's added as a layer called as self attention layer. Okay, so there are other attentions as well, but self attention is the most popular. Okay, so that's what the 6th step is. Okay, so you have your sentence. Okay, you first convert it into you have your text, convert it into sentences, Every sentence is then split into tokens. Then every token, right, will be converted into root form with the help of stemming and lemmatization. Once that is done, then we will identify the stop words and remove those stop words from the sentences. After the removal of the stop words, the next thing will be to do the dependency parsing. Okay, that is understand the relationship between the words, each token that is present in a sentence. Okay, so right, this is a very huge concept in itself. Okay, so we will cover one type of dependency parsing and check okay, in the practical thing as well when we go ahead in the further session. Okay, so as of now, just understand dependency parsing is where we are identifying the relationship between individual words. Okay, so that's called dependency parsing. That is the next step that we do, right? Then the next step that we have, the seventh step is the POS tag. Okay, POS means, POS, as you know, parts of speech. Okay, so every word in the English language will belong to the 8 parts of speech that we have, right? We have in total 8 types of parts of speech. But as I said, okay, so we will not be okay, mostly because after the stop word removal we'll have only these 4 things: noun, verb, adverb, adjective. Pronoun will also come there. Okay, but mostly okay, these are the 4 types of parts of speech that we will be left out with, and we have to identify for every word what is its part of speech. Okay, what is it, what is its parts of speech? Is it a noun? Is it a verb? Is it a adverb? Is it a adjective? Okay, so for this also we have models which can do it. Okay, we have tools by which we can do the POS tagging as well. Okay, so right, this is the next step, right? So after identifying the dependency rule, then what we do, we'll take every sentence, okay, all the tokens, and for each token we will identify its right part of speech, whether it belongs to a verb, whether it will belongs to a noun, adverb, adjective, etc., etc. Okay, so I have just given an example right here, like Google something on the internet. Okay, so right, generally Google is okay, name of a company, so it should be a noun. But here, right, I am asking you to I'm asking somebody, let's say somebody has asked me a query. Okay, so can you tell me about machine learning? So I said, I don't know, please Google it on the internet. Okay, so that means what am I telling him? So here Google is not a noun. Okay, it's an activity, it's a verb. Okay, I'm asking him to search for the thing on the internet. So this POS tagging is very right, complicated. Okay, because English language in itself has some ambiguities. Okay, English language in itself has some ambiguities. So right, sometimes the same word will have different contexts and different it can be of different parts of speech as well. Okay, so this POS tagging is very complicated and it has to be done carefully. Okay, right. Then the next step, okay, that we have is the name entity recognition. This is a very uh, popular in itself. This in itself is a application of NLP. Okay, so name entity recognition, NER. Okay, what is a NER? Right, you have identified the tokens, you have identified what are their parts of speech. Okay, so barring right verb, adverb, and adjective, okay, you remove all of them, you take only the nouns. Okay, so take the nouns. Okay, these nouns are again passed to NER. Okay, only nouns will be passed to NER, and we are trying to identify what is the entity of the noun. That means, is it referring to a person, is it referring to a object, or is it referring to any organization, etc., etc. Okay, this information is very important to understand about the sentence. okay, to understand about the sentence, right? So okay, so right, I need to know what type of entity, what type of noun is present in my sentence. Then only I will be able to understand the sentence properly. Okay, so that is what name entity recognition is all about. NER is just to detect the presence of named entities. Named entities in the sense the type of the noun, what type of noun it is. Okay, if a person is there, we'll identify the name of the person. Okay, so we'll have the name of the person, we'll have the name of the organization that it is referring to, etc., etc. Okay, so all these information is very important for me to get the context of the right sentence. Okay, so right, these, okay, 8 steps we have covered until now, right? 8 steps. Okay, so right, okay, first we started with right, it is not complete, okay, it is not completed, so I'm repeating it again. Okay, so first step is to take the text, divide it into sentences. Second, sentences are divided into tokens. Okay, now third, tokens are converted into their base form or root form. Okay, 3 steps. Next, you take all the root forms. Okay, what we'll do, we'll remove the unnecessary words, okay, which are called as, right, which are called as stop words. We do the stop word removal. Okay, next, after removing the stop words, the next thing is to identify the dependency of every word with respect to other words. Okay, so generally dependency values will be given from, or attention will be ranging from 0 to 1. Okay, 0 means absolutely no relation, 1 means, right, very huge amount of our they are interlinked with each other, completely interlinked. Okay, so the dependency can be any value from 0 to 1. So we will identify the dependency of every token with other tokens in the sentence. Okay, so we'll do that. Once we identify the dependency, the next step will be is to, right, get the POS. Okay, so POS means parts of speech. So for every token, we identify what is the part of speech of that token. Okay, so so once this is done, once this is done, once this is done, this is right. Can you give me 1 minute? So once we identify the parts of speech, then the next step will be after the POS tagging, the next step will be identifying the name entities. Okay, so you identify what type of nouns, pronouns, etc., etc. Sorry, in a noun, what type of noun is it? Okay, is it what is a person it is referring to? What is the organization it is referring to? Etc., etc. We identify the entities that are present in the sentence. Okay, so now I got some information about the sentence. Okay, so the next step is chunking. Okay, so what is chunking, right? So see here, so when I'm passing it to, right, so first I'll describe you or tell you why chunking is required. Okay, what is chunking? It is very easy, but why is chunking required? That we have to identify. Okay, so let's say I have this machine, this is my machine or this is my model. Okay, so if I give, like for example, if I give the sentences without chunking, what will happen is in one sentence there might be 6 words, in another sentence there might be only 2 words. Okay, in one sentence, in another sentence there will be like 10 words. Okay, so right, when I pass these sentences directly to my model, to LLM model, okay, to LLM model, right, okay, to the final stage of the LLM model, then it is very difficult. There is inconsistency in the input size. Okay, so our model will not work. Okay, so if the input size is inconsistent, okay, right, then our model will not be able to process our data, right? So we will not have we cannot process the data with this inconsistent input. Okay, so what we need to do is we need to convert this input into a fixed length. Okay, the length of the input uh, I'm giving at any instance should be same. Okay, and that is what we call it as chunking. Okay, basically chunking is a process in which we group the individual tokens into one chunk is basically group of tokens. Okay, so that every chunk will have equal size. Okay, every chunk will have equal size. Now, right here we might get a doubt. Okay, so for example, if this sentence has 6, let's say I have decided that my chunk size is 4. Let's say my chunk size is 4. Okay, in that case the first 4 tokens, okay, of the first sentence, right, will be taken here. Okay, let's say this first sentence has 6 tokens. The next 2 tokens will come in the second chunk. Okay, and this will be grouped with the next 2 tokens of the next 2, like this. So right, okay, so this continues, right? This continues until all the sentences are converted. Okay, if there is any kind of, let's say in the last chunk, if I got only, let's say, two tokens present, okay, there are no more tokens present in your text, then what we will do, we will add some null tokens. Okay, we will add some null tokens. Okay, null tokens. This is called as padding. This is called as padding, right? Padding of the tokens. Okay, so right, this is exactly the chunking is, right? Why chunking is important? As I said, okay, in our language, right, our sentences, all the sentences might not be of same length. Okay, some will have more number of tokens, some will have less number of tokens. So if I give sentence wise, then what will happen, right? The length that I am passing, the input length that I am passing will be inconsistent. Okay, so in that case, our ML model or our DL model or our LLM will not be able to process it. Okay, so therefore what I need to do is I need to convert them into uniform length. Okay, that is what we call it as chunk. Okay, that's what we call it as. This process of converting, right, all the tokens into smaller groups is what we call it as chunks. Okay, so right, and this chunk size is one of the key parameters, okay, for any large language model. Okay, so right, and there are so much of research, right? Okay, those who wanted to do any PhD on NLP, right, this is one of the very crucial topics. There are so many chunking strategies. We can work on different chunking strategies. We can develop our own chunking strategy as well and test it and see the performance, because right, chunking will automatically, right, if you take a simple chatbot, okay, which takes a PDF document and gives you responses from that. Okay, so if I change the chunking strategy, automatically the response of my chatbot will also change. Okay, chunking strategy hugely impacts the response, chunk size and chunk strategy. Okay, there are so many, like there are 4 popular chunking strategies. Okay, you can do exploration on that. Chunk size also, right, like I can consider 512 tokens, I can consider 128 tokens. Chunk length, okay, chunk size will also affect the performance. So we can do a research on that and we can submit papers and we can develop our own strategies as well for doing chunking, right, with one model. Okay, and right, carry out some work on that. Okay, yeah, so this is basically the thing that is happening, right, the thing that happens in the end. Okay, so now I have my chunks. Okay, I have my chunks, which are basically the tokens. tokens, right? So every chunk will have a group of tokens. So I will pass this chunks or this tokens to, right, a ML model. I can pass this chunks or tokens to a ML model or a deep learning model or to a LLM, which can do the processing of this chunks. So this is exactly the steps that are involved. Okay, this is how it will understand, right? This is how it understands what exactly is present, okay, in a text, right? So there is one more extra step that is present. I will cover that, okay, right after this. Okay, so these are the 9 steps, right? These are the 9 steps that are required to build a NLP pipeline. That means these are all the steps at the front end or the basic pre-processing. You could consider pre-processing of your text before giving it to LLM. Okay, right? So okay, if I want to do an NLP task, so I have to if I want to build an NLP pipeline, then I have to do all these steps. Okay, then I can pass these chunks to my LLM model or machine learning model or deep learning model, and I can do whatever the task that I want to do it. Okay, so yeah, so right, understood. These are the basic tasks that are present in natural language processing. So if I want to do as I said, if I want to do anything in NLP, I have to be right good at these 9 steps, right? I should know how to do all this with the help of various libraries. Either I can use NLTK, Spacey, etc., etc., right? Okay, now after I do the chunking, I can pass this chunking to my ML model or deep learning model or LLM, and it will do whatever you want to do. Okay, for example, you want to do sentiment analysis, right? So I'll take the sentence, right? So I have a paragraph. I want to understand what is the sentiment of it. Is it a positive review? Let's say we want to do a sentiment analysis of let's say hotel review. Okay, so for a hotel, there is a review present. Right, user has given some review. Okay, so there are, let's say, thousands of reviews available. We cannot go manually and check every review and see with how many of them are positive, how many of them are negative, right? So what we can do, we will create a system, we will create a model, okay, or we'll create a project, okay, a system which will automatically take all those reviews, understand or analyze each review and see whether it is positive or negative. Okay, and in that way take all the reviews and finally tell how many of them are positive, how many of them are neutral, how many of them are negative, what are the main aspects in negative reviews, etc., etc., etc. Okay, so right, I want to do this kind of thing. So when I want to do this kind of thing, the first input to me will be a paragraph. Okay, so right, and from taking that paragraph, okay, I want to pass this paragraph to a LLM model. At the end, I will be using a large language model or a ML model or a deep learning model. Okay, but I cannot give that input directly. Okay, so the direct paragraph cannot be given directly. So I need to do some pre-processing. Okay, pre-processing. So or some NLP have to be done. What is that you do? These are all the steps. Okay, so these are all the steps that we will be performing, and these, after doing these steps, then I can pass it to my LLM model. It will understand and it will generate the response. Okay, so I hope this aspect is clear, and if you have any queries on this, please let me know. Any queries on this until this point? Yes, sir. Any queries? Anybody else? Anybody
No,
has
sir.
any queries? Okay. I hope everything is going well, right? Okay. So yeah.
Yes.
Yes, good, sir. If you pass this once we pass this process data to ML, DL, and ML, what different
Okay.
outputs we get? What we can expect from this ML, DL, and LLM? How it
So
differs?
yeah, whatever, like for example, as I said, based on the application, right? Okay, based on the application. So let's say I want to, for example, you are using, let's say, uh, mm, as I said, the same example. Let's take the same example of sentiment analysis. Okay, you have a paragraph text. Okay, now you have your review, right? This review will be given to your NLP pipeline. Okay, so NLP pipeline will pre-process or will do the processing, and it will generate the chunks. Okay, these chunks will be then passed to, let's say, a machine learning model, a simple ML model, which can be, let us say, a SVM model is there. For example, SVM model is there. Okay, so what does the SVM model do? So it will take the chunks. Okay, it will take the chunks, right, and it will process the chunks. Okay, and it will say whether the given chunk or whether the given text is positive or negative. Okay, is it a spam one or a not a spam one? Okay, or let us say I want to do some text generation. Let's say you have asked a question, can you explain me about machine learning? Okay, so we will take this as the input, pass it to the NLP pipeline, it will process and it will generate the chunk. Now this chunk will be passed to LLM. LLM will take that chunk and it will generate the required context. That means it will take those keywords and get the information about machine learning from various sources, and then it will give you the required answer. Okay, so the machine learning model or the deep learning model or the LLM will do the required functionality, whatever you want. Okay, so before that, uh, the raw input we cannot directly pass to the LLM. We have to, or machine learning model, we have to do some processing. That's what we are calling it as NLP. NLP is basically like pre-processing the text, doing whatever is required so that we can pass the data to the LLM. That's the thing, sir. They will make the decision. They will do the decision making, or they will perform the text generation, etc., etc. Whatever is your required functionality, whatever is your desired functionality, that ML or DL model will take care of. Okay, is this clear, sir? Yeah, thank you. And any other query? Show me the slide. That is step 3. Okay, you want me to show that step 3? Yeah, step 3 is basically stemming. Okay. So yeah, I think everyone is clear. So let me continue from here. Okay. So what are the challenges that we face in when we are implementing NLP? Okay. So as I said, right, there are two major challenges that we face whenever we are doing something in NLP. One is ambiguity, second is uncertainty. Okay. So right. So these two words, I think we might have heard about them before as well. Okay. And I told you before as well, right? Ambiguity. Okay. Right. So what is ambiguity? Ambiguity means, right, something where we have some confusion. And simple, we can say some confusion. Okay. So confusion means, right, you don't have a clear understanding of what it means. Okay, a clear cut picture is not available, so that's called ambiguity. Okay, and we can have in English language there are 3 types of ambiguities, not one, right? So you have lexical ambiguity. Lexical ambiguity means, right, so whenever a single word, okay, has 2 or more possible meanings, right? So if you have, okay, 2 or more meanings for a single word, then definitely whatever the ambiguity we get is called as lexical ambiguity. Okay, like for example, Manya is looking for a match. Okay, so here, right, match means, right, it can be it can be a simple like she might be looking for a wedding. Okay, so she might be looking for a good marriage proposal match, or right, she might also be a player and she might be looking for a cricket match or a football match to play, right? So it the word match has multiple meanings, right? So we ourselves sometimes are not sure what is the exact meaning of it. Okay, so this kind of ambiguities are called as lexical ambiguities. This type of ambiguities are called as lexical ambiguities, right? And they will appear whenever, right, a particular word has two or more possible meanings, right? So as I think this is clear, right? Then there is another thing called as syntactic ambiguity. What is syntactic ambiguity, right? So let's say, right, you can understand this sentence. I saw the girl with the binocular. Okay, right here, right. So here we are not sure whether the sentence means that I am watching the girl with a binocular, or I'm watching a girl who is having a binocular, right? So we are not sure what is the exact meaning, isn't it? So it can be both. It can be either of the two. That means I might be watching a girl with the help of a binocular, or, right, okay, I am watching a girl who has a binocular in her hand, right? So both are possible. This kind of ambiguities are called as syntactic ambiguities, right? So this is one of a major concern when we are doing NLP, right? Whenever we are doing the natural language processing, this is one of the major concerns, syntactic ambiguity as well, right? Then referential ambiguity, right? So referential ambiguity means, right, okay, so like you are using pronouns, right? When we are using pronouns, right, it there are words which might refer to either the first person or to any object as well. Okay, so example, Kiran went to Smita, she said I am hungry. Okay, so Kiran went to Sunita, sorry, she said I am hungry. So in the above example, you don't know who is hungry. Okay, Kiran or Sunita, assuming both of them are female. Okay, let us assume both of them are female. Okay, so right, we are not sure who said this, right? She said I'm hungry means, this she, is it referring to Kiran or is it referring to Sunita? That we are not sure, right? So this type of ambiguities are called as referential ambiguities. Okay, so all these, right, all the presence of these ambiguities are actually a very huge task to understand when we are doing the NLP, because, right, a simple misleading thing can completely change the context. Okay, isn't it? So completely change the context, completely change the understanding of the things, right? So these are the major challenges whenever we are implementing a NLP pipeline. Okay, so we have, okay, lexical ambiguity, right? Lexical means whenever for a same word, if there are two meanings, okay, that's called lexical ambiguity. Syntactic ambiguity means, right, so we are not sure, okay, whether the sentence is talking, means for the entire sentence, if there are two possible ways of interpreting, then it's called syntactic ambiguity. Okay, so if I can interpret the sentence in multiple ways, I call it as syntactic ambiguity. Okay, referential ambiguity means, right, if you're not sure where that particular word is pointing to. Okay, so that's called as referential ambiguity, right? So these three things we call as right, the ambiguities, and they are major challenge whenever we are doing something in NLP. Okay, so I hope this is clear, right? So right now, till now we have covered a basic introduction to NLP. NLP has two components, right? NLP, natural language understanding, natural language generation, NLU, NLG. Okay, so then Again, next we have seen what are the applications, various applications of NLP where we can use them, right? We have given a list of applications. Okay. Then next we have seen what are the steps, right? If I want to do any project or if I want to do any task on NLP, what are the steps that are involved in that? Okay. We have around 9 steps that are involved that are need to be performed. Okay. Right. And then finally, right now we are seeing what are the libraries that are required to be performed, okay, or that are to be used for implementing NLP. Okay, so yeah, these are the tools that we have. Okay, sklearn, which is also called as scikit-learn. This itself it's a library which has all the machine learning things. Okay, so a wide range of machine learning algorithms are present in that, so we can use sklearn, right? And it also has a few functionalities for performing NLP as well. Okay, we can perform NLP tasks also using sklearn, right? Then second, as I said, NLTK, Natural Language Toolkit. This is the most popular, language library that is used. Okay, almost 85% of the industry uses NLTK because it's very simple and it has a complete toolkit. Okay, you can perform all the tasks using NLTK, right? That is the thing. And then pattern, again, this is also a module by which we can implement NLP things. But this pattern is specifically used whenever you want to get text from websites. Okay, so you want to do web scraping, right? If I want to get text from the any website data from Flipkart, Amazon, like that, when I want to scrap the data from there, then I'll use pattern. Okay, then text block, this is a simple library. It is not used for much of the complex tasks, but it does very well for simple tasks like sentiment analysis, noun phrase extraction, POS tagging. Okay, so these simple tasks can be done with the help of text block, and it is also one of the widely used because whenever you want to do simple operations, okay, text block will be very small in size, and it is very fast, okay, effective as well. So that is the thing. Then QPy is again one of the tools. This supports DB language. Okay, that is database query language. So if I want to work with some SQL databases, okay, or some clusters, cloud clusters, at that time I can use QPy. Okay, Spacey, again an open source NLP library for wide range of tasks. So if you are not using NLTK, then the other option will be Spacey. Okay, but Spacey models are like more complex. Okay, they are based on TensorFlow, where NLTK are based on PyTorch. So NLTK is easy to implement, whereas Spacey models are actually built on TensorFlow structures. So they are little complicated, but they also give good performance. Okay, then GenSim is again for handling large data streams, large data sets. Okay, it is also useful for generating data from the websites, scrapping things. All these things also can be done. Okay, so these are the few libraries that tools that are useful whenever I want to do some task in NLP. Okay, yeah. So this is the list of libraries. Okay, yeah, and we will be covering NLTK, Natural Language Toolkit. Okay, so as I said, my first part is done, but one concept I've left out. Okay, one concept. As I said, there is a 10th step. Okay, whenever I want to do some basic things. So I have covered 9 steps. There is one more step. Okay, that I will cover when by taking a particular application. Okay, so these 9 steps we have covered the theory. Now let us cover them in the practice. Okay, so let's do some hands-on. So I hope all of you have your systems ready. So I am hoping that you are joining through systems. So is it okay for if I do it from Google Colab? I think all of you have used Google Colab, right? Is that fine, sir? Anybody has hands-on exposure on Python libraries, Python things? Okay.
Yeah. So Python normally will use the notepad will run the application, sir.
Okay, sir. So I hope all
Usually,
of you are aware of how to install libraries as well, sir. Like NumPy, Pandas, if I want to install.
yeah, if
Yeah,
possible, you can explain, sir. Or else, if it is a time consuming, you can skip that one.
sure, sir. Sure, sir. Okay, I just want one library to be installed. So I will show that how it to be done, and then that's why I wanted to go with uh, Google Colab, so that because it doesn't require any explicit installations. Yeah, fine. Anyways, I'll just cover it up and then I'll take it up. So let me take one new folder. I think everybody knows how to run a Python program. So simple. Let's take so main.py. Let's say like this. Okay. So sorry, I didn't rename it. So so this is my okay Python file. So you know how to run it. For example, okay, so I can I want to edit it. So let me just put some code into it. Okay, so let's say I just want to print some hello. So running it, command prompt. So Python main.py. Okay, so this is how we execute. Right now, as I said, we want to install NLTK. So for this, right, okay, so these are the three steps. Okay, you can just have a note down or record as well, so whatever is required. So this is how we first need to install NLTK. So this is the first step. Okay, so first go here, then say pip install NLTK, pip install NLTK. So I already have it, so that's why I get requirement already satisfied. Okay, so if you don't have it, it will get installed. Okay, so right, so please I request everyone to install it, because the session will not be interesting, or you will get disconnected very soon if you're not practicing it on yourself. Okay, so okay, you can do it from your mobile as well. If you don't have your laptop and if you don't have your setup ready, that's also fine. You can go to Google Colab on your mobile and do it. Okay, so in the Google Colab, just say like this. So uh, let me open this. Okay, so yeah, this will be your Google Colab, so you can directly start writing the code here. So I'll just say pip install, or because it's a command prompt, so put a bash before pip install NLTK. Okay, and just run it. So yeah, it will take couple of minutes, not much, but I already have it in my Google Colab as well. So it's why. Okay, so the if it is not present, it will automatically download it and it will run it.
Sir, when I try this command in command prompt, no, this pip install NLTK,
Okay, sir.
it is getting that pip is not as a recognized command.
Okay, so then you don't have Python, sir. So first check whether Python is there or not in your system. So if I
Okay.
type Python, I should get something like this, sir. Please check, sir. So if you don't find Python, then simply what you can do is go to Python here. Sorry, python.org and download any of the stable versions, sir. So I'll have Windows here. Okay, so these are the stable releases, these are pre-releases. Don't go for here, go for here, stable releases. So not the latest one as well, because that will disturb the system. So you can go for any version before that. So I will take, let's say, 3.1 9.12. So you just need to click on this Windows installer. Okay, Windows installer 64-bit. Okay, so Windows installer 64-bit, it will install this, it will download this. Okay, so already I have this, so it is asking for upgrade. Okay, if not, we can download it, we will be installing it from right away. In that case, go to right, so on the first screen, okay, let's say I'll take this 3.10. Okay, so there is one very important mistake everybody commit, and very important thing is, so don't say install now. Okay, never directly install the Python like this. Okay, it will always create issues. So what you have to do is, you have to add, check this one, add 3.10 to the path. This has to be done mandatorily, otherwise it will not recognize. Second, go to customize installation, never go for this one. Okay, go for this customize installation. Okay, on the second feature, so I'm repeating it again. First you have to check this one, check this box, add Python 3.10 to path. Okay, so this is mandatory, it is required. Then go to customize installation. Here we don't need to do anything, all will be checked. Okay, just say next. But here is the case, so we need to check all the things. Okay, so we need to have debugging, right, symbols, we need to have standard library, all these things. If these are not present, you will get issues. Okay, so we have to check all these and then say install. That's it, it will get installed. Okay, so if anybody doesn't have Python, please do this. Okay, in this way, then all your issues will be sorted out. Okay, yeah, I hope this is clear. If anybody is facing difficulty, please let me know. I'll repeat the step again. Oh, okay, but anyways, I want to be in Python. Okay, so just check. Okay, if you are able to install NLTK. So has everybody installed? Anybody facing any difficulty? Please, your response is required,
Yeah.
because it cannot be a monologue. Sir.
Yeah, as you said, sir, we have checked the customization. There, I have checked all the checkbox. It is installing, sir. Yes.
Okay, sir. Okay, fine, sir. I think, well, let's wait. It will take 1 or 1.5 minutes, not more than that.
Sir, it was installed. I got a message that it was installed successfully.
Install successfully. Okay, sir. So now you can close the command prompt, open it back again, and then try Python, sir.
Yes, sir. It is the Python 3.1, 2.4. Yeah, it is showing. It is recognizing the
Correct, sir.
command.
Okay. Now you can just okay. So just install that NLTK, sir, using pip install NLTK.
It's installing, sir. It's saying installing packages and all.
Okay, sir. Okay, sir. It will take only 1 more minute. I
Yeah,
think.
it is. I got a message like a new release of PP is available 24.0. Then I think it is installed, sir.
Okay, sir. Fine then. So let's go to the next step. Okay. So now the next thing is, so we have installed NLTK, but as I said, NLTK comes up with all the different tools and libraries. Okay. So we need to download them into our system to use them. Okay. So for segmentation, sentence segmentation, for tokenization, for lemmatization, okay, stemming, etc., we require different tools. Okay, so all these tools will not be present when we install it. Okay, so what we need to do is we need to download them. Okay, so for this, what you do is like this. So okay, type Python. Okay, so when you type Python, you will get something like this. Okay, so just type Python. So you will be in the interpreter mode, that is the 3 arrows. Okay, this indicates the interpreter mode. Right now here, just type, okay, just type import NLTK, and press enter. Import NLTK and press enter. Okay. So it will do nothing, just okay, it will return. So we have written the import statement. Now what we need to do is we need to write this particular statement, NLTK dot download. Okay, so this is how we download all the components of our NLTK library. Okay, so NLTK dot download, right? Okay, inside the braces, inside here, I am not specifying anything. So that means I am downloading everything. Okay, instead of that, if I want only stemming model, or if I want only punctuation, that is stop words model, etc., then we can specify that particular thing. But here I want to download everything, so I'll just say nltk.download. Okay, so import nltk, then say nltk.download and hit enter.
Some pop-up came there.
Yes, sir. There will be a pop-up. Okay.
Download.
Yeah, my system is a little slow. That's why it is not at here. I'll show you, sir. Yeah. So yeah, you could have got.
Sir, I am doing this in Google Colab. So it is good, kya? It's okay.
Yeah, good. Not a problem. Go ahead. Not a problem. Yeah. So okay, so this is what you will get, right? You would have got something like this. Okay, so
Yes,
NLTK downloader, right? Okay, so I have already downloaded everything, so that's why okay, I have all of them in green, right? So just click on download. That's it. Just click on download. Okay, and you will it will take a few minutes, not more. Okay, so based on the internet speed, it will take 1 or 2 minutes. Okay.
Yeah, as
And
you said,
everything.
that corpora text and all it is downloaded, correct?
Yes, sir. It will download, and everything will get into green color like this. Okay.
Sir, actually in Google Colab it is written that which package you want to download.
That's what Google Colab. You can type in the brackets. You can type it as all ALN.
Okay, okay, sir. In download, in downloads bracket.
In download nltk.download. Okay. We can have all ALN, just all.
Okay, okay, sir.
And if you face any difficult error there, just ignore that. I'll show you, know what to be done when required. Okay.
Yes, sir. There is an error.
That's what. Okay, fine. Not a problem. Not a problem. We can ignore it for now.
Okay.
But for me, all are in green color, sir.
Yeah. So if all of them are in green color, then everything is completed. So you can check the status. Everything is installed. Okay. Then we can close this. Okay.
Yeah, in status it is saying all are installed, all Copra, all NLTK book, popular test and third party.
Yeah, that is good to go. So just close it and type quit. Okay. So yeah, you will come out of this particular thing. Okay, sir.
Yes, sir.
Right. Okay. Now let us do. Okay. So our installations are completed. Okay. So right, we have. Okay. You can try this nltk.download all. If you are not getting it in the Google Colab, that's fine. I'll show you how to do it in the for the things. Yeah. So this is how we got to do. Okay. Pip install nltk, import nltk, and then nltk download. These are the 3 steps that we need to follow. Okay. Right. Now let us go one by one. Okay. So I will go here into the program. Okay. So I'll remove this. Let me take some sample text. Okay. So let's say anything we can take, right? So okay, let's say India have recently won the T20 World Cup. Okay, they defeated South Africa in the final. Okay, so right, Virat was the player of the match. Okay, just I'm taking some random sentence, right? So all right. So this is my sentence. Okay, I'm using triple quotes so that I can take multi-line sentence as well, right? Yeah. So this is my sentence. Okay. Now let us do one by one. Okay. I've just taken one simple paragraph, right? We can take multiple paragraphs as well, right? Not a problem. Now one by one. So first step will be to divide this right into sentences. Okay. So for that, okay, so what is the thing is, this is called sentence tokenization. Okay, we have 2 tokenizations, word tokenizer, sentence tokenizer. Okay, so we will first need to do the sentence tokenization. So let us take the sentence tokenization from, okay, nltk dot tokenize. Okay, so from nltk dot tokenize, right, this is the library. Okay, from nltk the sub library is tokenize. So here I have, as I said, in tokenize I have 2 types of tokenizers, sentence, word. So I will first need to use sentence. So sentence token, oh sorry, okay, tokenize, okay, is my thing. So from nltk.tokenize, import sentence tokenize is the import I have to do now. Okay, so I will just write, okay, let's say tokens is equal to, okay, tokens is equal to sent underscore tokenize of text, okay, and then I will print tokens. That's it. Okay, so this will do the first step. Okay, so tokens is equal to send tokenize, right? Let us run this program. Sorry, Python main.py. No module name. Okay, sorry, spelling mistake. Excuse me for that. Okay, nltk.tokenize, send tokenize. So you could see I am getting a list of sentences. The first sentence is India have recently won the T20 World Cup. Okay, they defeated South Africa in the final, and Virat was a player of the match. So we could see the three, right? The text has been divided into sentences. Okay, so you can take any text. You can read the text from a file as well, right? Okay, it's not a problem, right? We can take a file and read the text from the file as well, right? So whatever we want to do, we can do it. Okay, so this is how sentence tokenizer works. Okay, sentence tokenizer basically, okay, divides the sentences into, right, into individual things. Okay, so individual sentences, right? Now here there is right, like one thing that we have to remember. Okay, that is right, this is basically the default one is basically always English. Okay, NLTK basically treats the language, basic language, as the default language as English. But if you want to do something with Hindi or Telugu or anything, then we can download that particular library as well. Okay, as library as well, and we can do the processing of those languages as well. Okay, so it's just we need to specify the corpus. Okay, so here what I mean is, here you are downloading nltk.download. We are not specifying anything here, right? So default one is all the models for English language. Okay, instead of that you can specify, for example, for English it is en. Okay, for French it is fe, for Telugu it is tel. Okay, so that kind of for Hindi it is hi. Okay, so if I specify that particular code, that language model will be downloaded. Okay, that language model will be downloaded, and you can process that language text. Okay, so this you can take up later whenever you have time. You can check with that. Okay, right. So I am done with the first step. What is the first step? I am done with the, yeah. Anybody is facing difficulty at this point of time?
Yes, sir. That in the desktop I saved the file as main.py.
Okay.
And I have written whatever the content you told. But in command prompt while running, no, it is not opening that file.
Sir, for that, what we need to do is we need to do it in this specific way, sir. Like, for example, you cannot put this file directly on the desktop. Put it inside a folder, sir. Okay. So, like what I have done here, I have created a folder called new. Sorry, where is that? New folder 3. No, where is my folder? Just I've created. Here. So I have created a folder called new folder. Inside the new folder, move the file, move the Python file into the folder. Okay, and you open the command prompt from this folder itself. Like here, you have to open it from the address bar. Type it cmd here. Okay, type the cmd here, and we'll be opening up the command prompt inside the folder. Okay. So yeah, you could see the path. The path here presently we are in the folder. Okay. So if you have opened it generically, then you can navigate to this path by CD, by giving CD space the path. Okay, that also will work. Understood, sir? Is this clear?
Yeah.
Okay, sir. Please do it, sir. I'll wait. Not a problem. Others also, if you are facing any difficulty, please let me know.
Extension should be the file name. Extension should be main.py. So the file name.
Yes, sir. Yes, sir. It should be main.py. Sometimes what happens now, the file extension will be .txt itself, but we are not able to see it. So what you do is please there is a button called file name extension, right? Please enable it. Okay. So we might have converted into .py, but the extension might not be available. So it will be still taking it as text file only. Check it that also, whether it is, you should get this Python symbol, sir, then only it is a Python file.
It will show you the text content. It will be showing error in line 5. Send token.
Send a token. What is the error, sir?
It is showing the token send token invalid syntax is the same.
Invalid
Token-
syntax.
Token
Okay.
send tokenize text.
Can you just check like this? What has happened? So,
Oh, it is sent underscore tokenize.
yeah.
If possible, could you ping that text now, sir, in this group chat?
Okay. So okay, I will.
From NLPPS tokenize import send underscore tokenize. Oh yeah, spelling mistake. Yeah, now it is working, sir. Thanks.
Now it is working. Okay, sir. Fine then. Okay, let's go ahead. So Right now, we are writing the program. Where is it? Yeah. So, okay, first step we have completed. Now, what we can do is we can take each sentence. Okay, we can write. So this is a list. Basically, it is a list, right? Tokens is a list, right? So now what I can do is I can take each sentence and then pass it to a word tokenizer. Okay. So, right, okay, we will take this same thing again. So I'll take this import. So from, okay, I'll write it here itself. So from nltk.tokenize, instead of sentence tokenizer, now I will take word tokenizer. Okay, so word underscore tokenize. Okay, so now what I will do is, so I need to have a loop. So for, okay, token in tokens. Okay, that means I am taking each sentence. Okay, so I'll write here sentence. So I'll also name this as sentences. Okay, so we are getting sentences, right? So I am just, okay, sentences for sent, that is each sentence in sentences. So what I need to do, I need to have the tokens. So let's say word tokens. So tokens is equal to, right, okay, so simple word underscore tokenize, word underscore tokenize of sent. Okay, so I also need to, I just want to print this tokens. So the next step is to convert all the sentence. Okay, to convert the all the sentences, each one by one, right? I want each sentence to be, okay, right, taken as a token, separate token, right? So, okay, so I'm passing every sentence and then I'm tokenizing it, okay, at the word level, right? So let's run this and see if I get any error. Python main.py. So you could see, so I have, okay, first the sentences, the text is broken down into 3 sentences. India, okay, right, they have defeated South Africa in the world, in the final, Virat was a big. Now what happened, we taken every sentence, right, every sentence, and again this every sentence is, right, split into, okay, individual words. So, okay, so even the punctuation marks, like no, full stop, we didn't use other punctuation marks, we have only, okay, the dot here, so that again is taken as an individual thing, right? So a separate token for this. Okay, so this is how I'm going to get the word tokenization, right? So, right, any queries in this? Is this clear, understood?
So would you share your that file, Sam?
Sure. Okay, so I will share this next command.
Yeah, that is all.
Okay. So anybody is facing any difficulty? Everything is good, right, until this point? Okay, so here I will just do one more thing, right? Okay, so the thing is, now people got fed up with this. Why should I first convert the text into sentences and then again sentences into tokens, right? Words. Okay. So why do I need to do all these steps repetitively, right? Two steps again, I have to do it repetitively, right? So why should I have two steps? Okay, instead of this, okay, can we do entire thing in one go? Because anyways we don't have the importance of sentences, right? Sentences doesn't matter for us, because when we are ultimately doing the chunking, we are not following any sentences. Okay, so what we can do is, we also have something like this. Directly I can convert. Okay, so let's say alternate. What is the alternate we have is alternate we have. Okay, alternate method is, okay, so I can directly go for the word tokenization, okay, instead of the sentence tokenization, right? So let me show that. So instead of giving this sent now, I will give directly the text as the input to this. Okay, so just check this. Okay, so now tokens is equal to word underscore tokenize, or okay, so here, right? So let us run this. I have saved it. Okay, let me run this. So you could see, right, earlier I have, okay, first, okay, the first method I have got individual sentences, then I did the tokenization, okay, that is converting them into words, right? Now second time what I have done, I have taken the entire text and directly got the words from them as one list. Okay, as one list, right? So here I was getting three lists. When I use this approach one, okay, I have three lists. So I have to apply everything in the loop manner. Okay, I want to remove the stop words. If I want to remove stemming, lemmatization, again and again I have to put the loops and do it. Okay, so this approach looked little complex. That's why we got, okay, word tokenizer itself can do everything. That means it can convert the given text directly into words. Okay, so you don't need to use the sentence tokenizer. Okay, so this is the alternate thing, right? You got it? You understood, right? So instead of step 1 and 2, we can directly go for this one method, which will give us all the tokens, right? And the advantage that we got here is, we are getting everything, all the tokens, all the words in one single list rather than multiple lists, so that I can do the filtering, or I don't need to do the looping again and again, right? So that can be avoided, okay, completely, right? So that's what exactly is happening up till this point. Okay.
Excuse me,
So
sir.
yeah, sure,
Sir,
go ahead.
can you share this recording to us?
Recording, I don't have the recording, sorry.
Because I'm not able to do right now this experiment.
Okay, no problem. I'll share the code. Okay, I'll share the presentation as well. Not a
Yeah,
problem.
better
Okay.
that the step by step. That third step you could have shared in the chat box.
Sure. I will. Alternate method. Okay.
Yeah, this one correct.
Okay. Done. So right, so we got up till this point. Okay, next step is, right, so let us go to, okay, so first what I will do is, instead of stemming and lemmatization, okay, I'm just altering the process a little bit, but it's but nothing disturbance will happen. So first what I'll do is, I'll remove the stop words. Okay, so there are so many stop words, right? So I just want to remove the stop words. Okay, so for removing the stop words, okay, so right, first I need, as I said, okay, I can have two methods, right? Stop words, I can define myself what are called as stop words. Second, I can download the stop words list from the corpus, from the NLTK library itself. Okay, it has a huge amount of a huge number of stop words already defined. Okay, so let us do that method. We can also define ourselves as well. So let's say I will define a library called stop words is equal to something like this. Okay, I'll write all the words that are possible. Okay, so if, okay, but all these etc is, was, etc, and I can check only for that list. Okay, but here I'm not doing that. Okay, instead I'm going to download, okay, the list of downloading the list of stop words from the, okay, NLTK library. So I just want to download the stop words from the NLTK library, and then I want to remove those stop words. Okay, so how do I download first? Okay, so because we have already said nltk.download, everything will be present. Okay, if not present, okay, those who are using Google Colab, for Google Colab you type like this, nltk.download, okay, and say stop words. Okay, this command will download the list for, okay, in Google Colab, those who are doing it in Google Colab. Okay, for other people, sorry, stop words, I think this space will not be there. Yes, I think correct. So okay, so NLTK, sorry, this NLTK.download, okay, stop words. So let me run this here in Google Colab. You will understand code. Okay, so why is this coming? Because I am import. Okay, run this. Now done. Now you say nltk.download stop words. Okay, so this particular, right, package will be, right, downloaded in the same way, because we have downloaded everything in our command prompt. Okay, in our system, I don't need to explicitly download it. Okay, I just need to import it. Okay, so how do I import it? Simple, right? Okay, so from nltk dot corpus. Don't think that, okay, these now all these commands we have to remember. No, if you start practicing, right, it all these will be on your fingertips. Okay, only a few commands will be there. Okay, so we just need to remember those things only, right? Once you build a couple of pipelines yourselves, NLP pipeline yourself, you will get well versed with them. Okay, it's just we need to practice. Okay, so yeah, from nltk.corpus import stop words. Okay, so this will download all the list of the stop words that NLTK has. Okay, corpus has. Now once I do this, so as I said, I need to check, right, for all the words. Okay, for all the words, whether they are actually present in the whether they are like, I have the list of words. Okay, I need to pass every word and check whether it is a stop word or not. Okay, so that's the exercise I have to do. Okay, so for that, first what I will do is, okay, I will get the list of stop words. Okay, so in a variable. Okay, so I'll do the commenting as well so that you can understand later on. So create or get the list of stop words into a variable from the corpus. Okay, so stop underscore words is a variable now. Okay, this will have all the available stop words. Okay, so I have to,
Sir, from which corpus it takes words?
NLTK corpus, from the English language corpus.
It means a whole complete language corpus words.
Yeah, complete language. NLTK has a list of stop words. We can print this, sir. We can print this and say and see it. Okay, so I will show you after this particular command. Okay,
I mean to
so
say, sir, like from NLTK, that package, you are there are predefined stopwords are there in that package. From that package, you are filtering our stopwords, no, sir?
yes, sir. Yes, correct.
That's
From
what
that
you are
package, I am
matching.
going to get it. Okay,
Yeah,
so huh.
in our text, are there any stopwords that are matching to the NLTK package? If they are matching, we are removing that one, no, sir?
Correct, sir. Exactly. So what I'll do is I will get the list of stopwords from the NLTK library, and then I will compare whatever the token, every token in my text. I'll compare whether this is present in this thing or not. If it is present, means that can be treated as a stopword, so I'll remove it. Okay. If it is not present, means it is it's not a stopword, so I will keep it in my text, sir. That's it. Okay, comparison I will do, right? Got it, sir? Any doubt on this?
Oh, it's very clear, sir. Yeah, thanks.
Thank you, sir. Okay, so get the list of stopwords into a variable. So here I am going to specify English language. Okay, so you can specify any language that we want. Okay, so every language has a few stopwords. So based on the corpus, based on the language we got, we can decide what exactly we want. Okay, right. So for the time being, okay, I just want to write. I just will print this. Okay, and see what are the stopwords that are present in the NLTK corpus. There will be a huge list. Okay, but let's see, right? So okay, so this up till this point is right, our previous data. From here, right, you could see from here, this is the entire list of stopwords that you have in the NLTK English language, like is, because, there, is not, doing, them, theirs, they. Okay, all these things, okay, re, by, your, and further, conjunctions, prepositions, all these things will be taken as stopwords are here. Okay, these are all the list of stopwords that we have. Okay, now what we need to do, we need to write a loop so that we will pass every word to that every word from my input sentence. Okay, check whether it is a stopword or not, and finally if it is a stopword, I will what I will do, I will remove it. If it is not a stopword, I will keep it. That's it. Okay, just write a simple loop. Okay, so I will take every sentence. So let's yeah, let us create some first an empty list. Okay, so I will say filtered list, means I want to store, okay, the ones that are not stopwords, right? So I just create a empty list. Okay, filtered list, right? Now in this, so for, okay, every word, for word in, okay, so what is the variable that I'm storing, where I have this one, tokens. So for word in tokens, okay, for word in tokens, right? So okay, what I want to do, I want to check, okay, I want to check if my word, okay, if my word, okay, but here one simple thing, right? Word can be in upper letter, or uppercase, or right, lowercase. Okay, so that is also important, right? So I want to convert them into everything into, right, one case, like I want everything to be lowercase. Okay, so you could see here all the stopwords are everything in lowercase only, right? So if I, let's say, down is there, okay, if I give capital D, right, it will not be matching, so it will not take it as a stopword. Okay, similarly if IT is there, okay, if I have capital I, then that will not also be taken as a stopword, so we'll get unnecessary things. So what I need to do, I need to convert all these things into lower. So what I'll do is I'll write like this, case fold. Okay, what does this do is this will convert, okay, all the cases. It can be title case, camel case, anything, right? Uppercase, lowercase, everything will be converted into, okay, and into, right, lowercase. Okay, so if word dot case fold not in stop words, okay, if it is not present in stop underscore words, okay, then what I need to do, it will not, it is not a stop word, so I will just append. Okay, so I will, okay, take this list and I'll say dot append. That's it. Okay, so what I'm doing is I'll explain this again. So I have put an empty list. This is just an empty list. Okay, so what I'm doing, I'm taking every word that is present in my tokens. Okay, tokens is what, right, the words that I got after tokenization. Okay, so I take each word, right, and this word first I will convert it into lowercase. Okay, and I'm checking whether it is present in the stop words or not. If it is present, I don't need to do anything. Okay, if it is not present, then what I will do, I will just, okay, because if it is not present means it's a required word, it's not a stop word, so I just add it, or I will just move it to a new list, this filtered list. So this filtered list will have all the words which are not stop words. Okay, so if I print this filtered list, okay, right, I will see the output. So I'm removing this particular column. Clear until this point? Okay, so let us print it and see, let us run it and see, and yeah, if there is any error. Okay, sorry, list dot append, we have to give something here, right? So what is that we need to append? We need to append word. Okay, correct. So okay, now see here, the first is this array. So I had India have recently won the T20 World Cup, etc., etc., right? Out of this, okay, India is present, have is a stop word, so it is removed, recently has come, one, the, right, this are all gone. Okay, these are also taken as stop words. Okay, T20 has come, world has come, cup has come. Okay, dot also has come because it is not included in the stop word. See, you could see there is not presented. Okay, we'll remove it in another way. Okay, we'll remove it in another way. I'll show you how that is done. Okay, then defeated has come, south has come, Africa, final. Okay, pa, Virat and go. So there are certain words that are removed, which are taken as the stop words. Okay, so we can also write like this. For example, let's say here. Okay, so I'll just comment out this line. Okay, and I will say, I told you we can give stop words in two ways. One is the default one that we got. Okay, now the second one is like this. So I will give, okay, I will give a list like this. Okay, 8 comma, okay, let's say dot, next the, okay, comma, he. Okay, what else can we put? Okay, what else is there in my text? In I can put in. Okay, let's just put these things. Okay, so okay, right, so now what I'm doing, instead of the stop words taken from this corpus, I can use my own set of stop words. Okay, based on my application I can decide, right? So I can do it myself, right? And now let us run this. Let's see what is the error we get, or we'll execute it. Okay, let's see what is the output now. So now you could see, right? Okay, so here, okay, you could clearly observe that there is no punctuation mark. Okay, dot is removed, right? Okay, have, it was not coming earlier because it was present in the stop words there, now it is coming. here. Okay, India have recently. Okay, you observe the difference. Okay, this is the stop words from the corpus directly. This is right the stop words from our own list. Okay, in either way we can do it. In either way we can do it. These are the two methods, right? So this is the next step, right? Huh. Any queries in this? Understood? Is this clear?
Yes, yes, sir. We are able to follow. Yes.
Yeah. Okay. Uh-huh. Thank you. Right. Let's go to the next step. Okay. So once the stop words are removed, okay. So now the next step will be right stemming and lemmatization. Okay. So let us take stemming and lemmatization. Okay. So I hope this particular thing code also, should I keep it here? Okay, I'll do that. I'll do that. Okay, let me quickly put it and then do that.
Sir, at the end, you can share the file directly, complete file.
Correct. That I'll do, sir. Yeah, sure. Okay, so let's go ahead. Next. The next thing is, as I said, stemming. Okay, so right, stemming of the sentences, stemming of the tokens. Okay. Now for stemming, right, we need a tool called as stemmer. Okay, so okay, here we have there are various types of stemmers that are available. Okay, there is a porter stemmer, there is a snowball stemmer. Okay, so there are so many kinds of stemmers that are available in NLTK. So we can use whichever is required for us. Okay, so we can there are like snowball stemmer will give you a little bit differently, whereas porter stemmer will give you a little better one. Okay, so I'm going to use porter stemmer. You can also search for snowball stemmer as well. Okay, so right, we will just import it first. Okay, so from nltk dot stem. Okay, from nltk dot stem import porter stemmer. This is the right stemmer. Okay, so right, so this is the import statement. Okay, so we need porter stemmer. If you want to use a snowball stemmer, that is also fine. We can just say okay, comma snowball stemmer. Okay, this is also fine. Okay, both of them will work. Okay, but I'm presently using only this porter stemmer. Okay, now from nltk.stem import porter stemmer. Right now what I need to do first, I need to go for okay stemming. Right, so I will initialize this. So stemmer is equal to okay porter stemmer empty object. Okay, I'll initialize an empty object and I will just say so stem words. Okay, so let's say words right stemmed. Okay, so after stemming, what are the words after stemming will be? So okay, we will go something like this. Again I can write it like this. So or otherwise, okay, what I'll do is I'll use a loop. So for again word, can you give me a second? Just give me a second. Yeah, okay, sir. Yeah, I'll speed up the things. Okay, I think already last half an hour. So yeah, for word in filtered list. Okay, for word in filtered list. Okay, So I have to take every word, okay, and then I have to do the stemming, right? So for this, okay, simple code, what I need to do is, so stemmed underscore words is equal to, okay, so I will take as a list stemmer dot, okay, stemmer dot stem. That is a function that I want to do, okay. So I will take, right, word, okay, stemmer for word in words, okay. So I'm just simplifying. I'm putting everything in one line, okay. So stemmed word is equal to stemmers dot stem, okay, stemmer dot stem of word for, right, word in words. Simple. So what we are doing, we are taking every word, okay, in, sorry, not words, so this is filtered list, featured list, okay, filtered list, okay, yeah. So I will take every word in the filtered list, okay, and I'll pass that word to stemmer, and I'll get the response. I'll put it as a, I'll put it in the this particular, right, variable that is called as stemmed words, okay. So let me execute this, but so I'll put print so that we can see how the stemming has happened, right? So okay. So okay, so now you see the difference. India is India itself, okay, it's not a problem, okay. So recently become recent, okay. So ly has been dropped out, one has become one, T20 world cup, they defeated became defeat, okay. South become South, Africa as Africa, the final. So this, okay, okay, I purposefully wrote this just to make sure that it is evident in stemming, okay. So the final, because it is taking, right, I told you stemming will remove the last part. So whenever it sees the suffix or prefix as al, el, okay, ly, something like that, it will take out. So because it got al here, right, it removed this particular part, okay. So virat is virat, was again become, s has been removed, okay, as a suffix, okay. So this become like this, and potm become potm, okay. So this is what is exactly happening when we are doing, right, okay, right, stemming, okay. So now to avoid this, we can go for, right, lemmatization, okay. But because I don't have much time, so what I'm doing is I'm going with other other things, okay. So let us go for okay, let us go for the other applications, okay. So other functions, okay. So now, until now, what we have done, we have got a sentence, we have got a text. This text we are able to divide it into sentences, we are able to divide them into words, okay, every sentence into words, or we can directly convert the entire text into words, okay. That we have done. Then next, what I have done, I have removed the stop words from it, I have done the stemming, okay, or lemmatization, right. Now what I do is, okay, so I will, right, I will go ahead with the POS tagging. POS tagging means parts of speech, okay. So let me go for POS tagging, okay.
Sir, I have one question, sir.
Yes, sir, sure, sir, sure.
After stemization, the words are getting changed. The meaning, it may lead to different meaning of the sentence.
Correct, sir. Yes, there are words which are like for example, was
Yeah, was.
affected, the
Yes, yes.
final was affected. Yeah, sir, that
Now, how to take
happens.
care about that?
Yeah, how to take care about it? Because instead of stemming, we have to go for lemmatization, sir.
So with that lemmatization, was will remain as was only.
Yeah, was will remain as was only, sir. Correct. It will remain as was only.
Okay.
Yeah, it's just a simple change of it. Okay,
Okay.
we
It
can
looks for dictionary because it looks
uh,
for the dictionary. It will replace was. It will replace was as was only.
Yeah, sir.
Is it?
So
Okay.
if you want, I'll just run it here itself. Okay, I'll just show it that way, that thing also, before I go ahead. Okay, so let me call it as lemmatization. Lemmatization. Huh. So first I need to get it. So again from nltk.stem, okay, from stemming itself. So here I need to, as I said, lemmatization is based on a library. So here that library is called as WordNet, WordNet, sir. So we need to have WordNet lemmatizer, lemmatizer. Okay, so WordNet lemmatizer. So this is the lemmatizer which uses WordNet library, which has some lakhs of words and their derived forms. Okay, so we can just use it. Okay, so let's say lem is equal to, okay, so again we just need to do the empty instantiation, and then finally just say, okay, so excuse me. So again I will write same thing. Okay, I'll just take this. Okay, so everything I'm putting everything in here. So lem words is equal to, so instead of stem, now I need to write this as lem, the model name. Okay, the variable name, we can give it anything. Okay, and we should say instead of stemming, I should say this as lemmatize. Okay, lemmatize, lemmatize of word for word in filtered list. Okay, lemmtiza, I think, yeah, correct. Okay, so right, print of lem underscore words. Okay, so let me run this and show you the difference. WordNet lemmatize. Okay, sorry. Okay, so yeah, now see the difference, sir. Okay, so we have the we can observe the difference. So this is stemming output, this is lemmatization output. So here recent, here it is taken as recently only. One, T20 World Cup, both are same. They defeat, here it is taking as defeated South Africa. South Africa, the final become the final. Virat was again is not taken here as well. So something wrong with this. Yeah, but yeah, this is how you can do the lemmatization. But that's a problem, why we don't prefer lemmatization is most of the words will be left as it is. Okay, so stemming is better when compared to lemmatization, but of course there will be some inconsistency. As you could see, there is, some words will get the thing, but it most of the times it will work better when compared to lemmatization. Okay, so this is how stemming happens, and this is how lemmatization happens. Okay, so we can experiment with multiple text so that we can get the idea about it. Okay, so that's the thing, sir. So this I think is clear. Now let's go to POS, parts of speech. Okay, so so POS tagging, where we will have to generate the part of speech of every word. Okay, so what I will do is, okay, I'll take so it's a simple one line sentence, so I can take it as POS underscore tags is equal to, okay, so NLTK dot POS underscore tags, no, it's only tag, POS tag, and give the list of the words. So let's say I'll give this lem words. Okay, print off. So I actually thought of taking one application and showing everything, but it is the basic processing itself has taken a long time. Sorry for that. Sometime later, when I come back, definitely we'll see. Yes, what has happened? NLTK is not defined. Okay, why is this? Okay, I have. Okay. Sorry for that. Okay, just I need to from code NLTK. So you could see, right? Okay, for all the words for India, it is like named noun. Okay, so recently, right? Something else. Okay, one verb. Okay, so we got all the list of right. Okay, every word and its POS tag. Okay, so okay, you could see that this is how POS tagging is done, right? So we have all the words and their okay POS tags, right? Now we can use this information and we can do whatever the processing that we want. Okay. Finally, right? Okay. NER, I'm not showing it here. Name entity recognition. That also we can do. Okay. But because of the time being, so what I will do is I'll directly go into chunking. Okay. So how we can convert into chunks. Okay. So let's take 1 second. Yeah. Can you give me just 1 minute? I'll join back. Yeah, sorry for that. Okay, so I'm back. So like the last step that we have, okay, is the right chunking. Okay, so we need to just create. Okay, we need to just create this whatever right we have done, text that we have done. Right now we need to okay do it with the chunking. Right, so we need to group them together with one uh, things, right? One group. Okay, so how we can do it? Let's do it. Okay, so for this, okay, we need to have like okay let's go to okay let's import the chunking, right? Here I need to write okay, chunk parser is equal to nltk dot okay regex. So I'm going to use a regex parser. There are so many kind of parsers that are available for chunking. So I'm just going to take a regex parser with some default grammar, means with some default understanding. Okay, so right, this thing. So you cannot like here we cannot combine everything, right, as per our requirement. Okay, there should be some grammar that is associated. Okay, so you need to first tell what is a grammar that we want. Okay, so right here I will, yeah, because time is not there, I'm maybe I'm going a little fast, excuse me for that. Okay, but we can later also come back to me. I'll so just okay, define a grammar rule. So I will say simple like this. Okay, I will write okay dt question mark, and this is just a parser. Okay, grammar. Okay, grammat. I will explain you what it is, don't worry. So let me write and then I'll explain you. Where is the asterisk? Yeah, asterisk, yeah, asterisk. And finally I will have noun. Okay, right. So this should be my grammar. Okay, so right, so what NP means is, NP means noun phrase. Okay, so every chunk should have one noun phrase. Okay, noun phrase means there should be one noun present. Okay, one noun present in your chunk. Okay, then the next one is, so there's the question mark. So what is question mark? It is a determinate. Okay, so it's called dt. Okay, so in your right POS, you could see there are like here there is nouns and then jj. Okay, and dt is not present here. Question mark is called as question mark, exclamation mark, right, asterisk, all these are called as dts. Okay, so right, these are called these are called as determiners. Okay, so they will they will indicate, right, what all symbols can be indicated. So here I'm saying that I can have an extra addition of question mark in my grammar. Okay, so I can firstly the first point is it should have a noun phrase. Okay, it should be a noun phrase, means noun phrase. Noun phrase means a noun followed by some 2 or 3 words. Okay, that's the first requirement. Second, it can have a dt, it can have a question mark, it can have a jj. Okay, jj means adjectives. Adjectives can be present. Okay, describing the noun. So jj is adjective. Adjectives can be present. Asterisk indicating that the length can be anything. It can be 2, it can be 3, the number of adjectives. And then nn means a proper noun. Okay, so a noun should be there. Okay, a dt, a discriminator, which can be question mark, anything can be there, and an adjective can be there in the chunk. Okay, this is the basic grammar that we have. Okay, so this right grammar we need to define. Okay, so chunking, that's why I said chunking is a huge topic. Chunking is not that easy, right? We can have various kind of chunking strategies. We can have chunking lens, chunking grammar, etc., etc., right? So this will give you, right, this particular grammar. Okay, now just what you have to do, you have to just write. Okay, so tree or some output, let's say output is equal to, okay, output is equal to, so chunk underscore parser, okay, of sorry, chunk underscore parser dot parse of your sentence. What is the sentence you got after the POS tags? Okay, this one. Just parse this to this particular chunk, then it will create the chunks. Okay, so this is right. Okay, what you will do, let us run this. You will understand. If there are any errors, we'll correct it. Oh, sorry, I have not printed the output, right? Okay. Print the output, and also I can also draw this. Okay, draw this as well. So I can just say output dot draw something like this. Yes. Now let us run this. So you could see this is how it looks like. Okay, the parse tree, the chunk tree for our given sentence. Okay, so this is the tree, this is the tree. This will give you the association mapping and the word similarity, everything, to your LLM model. So right, like this, your output will be looking like this. So you have created them into chunks. Now all these are different chunks, each of them is a different chunk. This you can pass it to your LLM model. Okay, and you can do it. Otherwise, for the machine learning model, I tell you there is one more step, there is one more extra step in case of machine learning, right? So what is that is, okay, in case of machine learning, there is one extra step. What is that extra step? Is vectorization. Okay, so you need to convert, okay, whatever the chunks you get, okay, into vector form, vectorization. Okay, so there are two popular vectorization techniques. One is called as bag of words, okay, Bow algorithm, right? Other is called as TF-IDF vectorization. So okay, for an ML or DL model, this is required. ML model or DL model, right? You require this particular process to be done. Okay, if you are using an LLM, that is like GPT model or Mistral or any other T5 transformer, BERT model. Okay, so BERT, okay, Distill BERT, any LLM model you are using, you can directly give the chunks. Okay, these chunks will be directly passed to your LLM model. It will make the decision making happen. Okay, it will do whatever you want to do. For example, you want to do a sentiment analysis or a spam detection, right? So you can give this chunks to them. Okay, then it will perform the operation that is required. Okay, so that is the thing. Okay, because of lack of time, right, even if I discuss these topics, it will take some time. Okay, bag of words, TF-IDF factorization, and again implementation of them, it will take some time, so I don't want to do that. Okay, I hope you understood the process, right? The entire process, from how you take, right, a single a text data, and how you generate the chunks. Okay, the chunk trees. Okay, so once this chunk tree is done, then we can pass it to ML model, and it will take care of the processing. Okay, so this is the process. This is what we call it as NLP, right? Here we have skipped two things. One is name entity recognition, we have not used. Okay, we can do that as well, right? That will give you named entities that are present. Okay, that we can do, right? We can also, okay, take each sentence and go ourselves as well. Okay, so yeah, so that is it from my side, right? This part is a little tricky, how to create the grammar and how to convert, only a question here is grammar. Okay, so how do you get this grammar generated? Okay, so for this, again, as I said, it depends upon chunking strategy. It depends upon what should be your size in real time. These are very key parameters that we consider for development. Okay, so all these will be very critical there. Okay, so this is what we call as the NLP pipeline. I hope you have understood. Any doubt in this?
If
Yeah.
there are no questions,
Okay. Okay, sir.
so,
So I think I am believing that I just gave you a brief introduction, right? The NLP domain is so deep, so it will take some time to get all the things. But I hope I have given you a basic understanding and curiosity to learn about NLP. So yeah, we can work on this, and definitely anytime you can reach out to me, sir. Yeah.
okay, sir. Nice, sir. Very good session, sir. We could learn a lot many things. It has been very effective, and most importantly, you have given the hands-on. It's really great. and definitely we'll have more sessions with you, sir, in coming days. Thank you for your precious time, because you are from industry. Taking out time for you may be very difficult. Thank you. Thanks a lot, sir. Definitely we'll have more sessions from your side, sir.
Thank you, sir. Thank you so much. My pleasure, sir. Thank you, everyone, for your patience listening. And I hope most of the people were asking some few queries as well. So all of them very attentive. So thank you for that. I would like to thank HOD sir, Praveen Sam, and Ashwak sir for giving this opportunity to be a part of this FDP. I hope this FDP will be a great success. Thank you all for your.
It's our pleasure, sir.
Thank you, sir. Yeah,
Sir,
yeah.
if you will please share your presentation and that text file, sir, the Python
Sure,
file.
sir. Sure, sir. Sure, sir. I tried to add it into the chat, but it is not
Okay.
happening. So I'll share
No,
it
you
with
can.
you, sir.
Yeah, share with me. I'll share with our participants. Okay.
Sure, sir. Sure, sir. Thank you, sir. Thank you.
Have a good day, sir.
సార్ శివ సార్ పార్టిసిపేట్స్ క్లోజ్ అని చెప్పండి.
Yeah, so you can leave for the day. The session is ended. Yeah, you can leave for the day.